Welcome to SysEng Quick. My name is John, and today I'll show you how to use GitHub Actions to automate the building of Docker containers. GitHub Actions are my favorite continuous integration tool. They're easy to get started with and have broad community support. I have my repository open in VS Code with a sample Docker file. I've kept it simple so we can focus on the GitHub action and not the container. The container just adds poetry to the Python 3.11 Alpine image from Docker Hub. On the CLI, building the image and pushing to a container registry is simple. We could do something like docker build-t gchr.io syseng quick container build workflow latest, supply the Docker file and the context. We would then log in to the container registry and push our container up. I'm not going to do that though because we want to build it in the GitHub workflow. So how do we get the same functionality in a GitHub action? Let's start by making a GitHub action workflow. A workflow is a configuration for GitHub Actions. It tells GitHub when to run these actions and what actions should be taken. We need to create a file in the GitHub Workflows directory. The file name doesn't have any special significance, so I tend to name them after what the workflow is doing. This one builds our container, so I've called it buildcontainer.yaml. Make sure the file name ends in .yml or .yaml. The first key is name, which will give us a more descriptive name for our workflow. Here I called it build container. The next key is on, which tells GitHub which events should trigger this workflow. I'll leave a link in the video description to the GitHub documentation, but we're only going to cover a few in this video. The first event is push, and as you might expect, happens when you make a push to the repo. We may not want every push to trigger this workflow, so let's restrict it to pushes on the main branch. We can do that with the branches key. This key takes an array of branches that we want to allow list for this event. When pushing to a branch, we can make further restrictions based on what files have been changed using the paths filter. Here we've added Dockerfile to our paths, so that we only trigger this workflow if the Docker file is updated. The other event is workflow dispatch. This allows us to manually trigger a workflow, which is helpful when testing, or if we want to build a container before we push to main. There are no keys under workflow dispatch, so we just leave it blank. The next key is env, which allows us to define environment variables across this workflow. I've added two variables here, registry and repo. Registry we've set to GitHub container registry.io, but you can put any container registry there. For repo, I'm using one of the built-in GitHub action variables, github.repository. This will give us the organization and the repo name. Here, that's sysengquick/container-build-workflow. For public GitHub, your organization is the same as your username, but this could be different on GitHub Enterprise. Our final key is jobs. A job is a group of steps that can be run on a GitHub action runner. Each key under jobs is the name of a job. The names can be whatever you like. They'll show up in the workflow logs, and you can use them to enforce job ordering in case one job must be completed before another. We're only going to define a single job here, build collection. The first key under our job is runs on. This tells GitHub what kind of runner it should use for our job. GitHub has runners for Linux, Windows, and Mac OS. Since we're building a Docker image, we'll use Linux. Our action has no particular version restrictions, so I'm going to use Ubuntu-latest, which is 22.04 currently. GitHub creates ad hoc tokens for each workflow run. By default, this token does not have package write permissions, which is required to push to the GitHub container registry. We can change that with the permissions key. We'll give our token contents read and packages write permissions. This will also work for GitHub Enterprise container registries, but you probably won't need this for private container registries. We're at the last key, but it's the most complicated. The steps key is a list of steps to be taken in this job. We'll need access to our repo's Docker file. Every workflow runs inside a container, so the first step will be to check out our repo. GitHub has a built-in action for this called checkout. The uses key is actually a reference to a GitHub repo, so you can go to github.com/actions/checkout to find more information about this action. Here we're using the v4 tag for the checkout action. Most of the time you can use the latest major version tags, but at times your runner may not be compatible. If this happens, check the repo documentation for more information. For example, if you're using GitHub Enterprise and your runners are on an older platform like CentOS 7, and the GitHub action is trying to use Node.js 20, the action is going to fail. Using an older major version of the action can often resolve issues like this. It's common to align the names of your Docker image with your repo. GitHub preserves case in the organization and repo names, but Docker image names must be lowercase. This step creates the image name environment variable by converting the repo variable to lowercase using a bash variable transformation. Next, we log in to the container registry. For this, we use an action from Docker called login action. We can supply parameters to actions using the with key. The GitHub actor variable corresponds to the user who triggered this action. And the secrets GitHub token is the ad hoc token that is created for each workflow. Repository authentication outside GitHub or GitHub Enterprise are outside the scope of this tutorial. Our next step prepares Docker buildx. Although it's not always needed, it is required for certain kinds of Docker container builds. I prefer to add it and not need it, than need it and forget to add it. Though if you don't need it, you can speed up your workflow by removing this step, though I don't recommend it. Our next step gathers metadata about our image for the Docker build process. We add an ID key here so we can reference the output of this step in the next step. The images key is the name of the container. The tags key is a comma-separated value of tags to apply to this container. If the workflow was triggered by a branch or a tag, we'll use those. We always add the latest tag, which you may or may not want. And lastly, we add the short SHA-1 commit hash. Our last step does the actual container build. As the name implies, it can also push the container to the registry, though it doesn't by default. The context key is the Docker build context. You usually don't need this, but if your repo has submodules, this action can fail if they're not checked out with the rest of the repo. Setting push to true tells the action to push your container after it's built. The labels and tags from our metadata step are added here as well for the build process. So let's try out our new action. We need to commit our changes and push them up. I've actually already made the commit, so all I need to do is push that up to our branch. Let's just do git push, and there we go. Workflows are often tied to the default branch, so it can be hard to test them outside that branch. You can temporarily change your branch name, but that can lead to other problems. So my recommendation is just to test your workflows in the default branch and not worry too much if you have a few commits that say fixing workflow again or something along those lines. Now we can go to GitHub and see if our action worked. Over in GitHub, I'll select the Actions tab, and you'll see it's running our GitHub action. Let's see what it did. We can open this up, click on Build Collection. It took 27 seconds. It set up the job. It checked out our repo. That was our first step. It generated the image name for Docker, logged in the container registry, set Docker. We got metadata, which if you look in here, we can see the image version is main. The tags are the tags we added. Here's our branch, here's latest, here's our SHA tag. Our labels came from our Docker image. And we also have our images as well. So here's our image name. Under Build Push Container Image, you can see what it did. It set up buildx, and then it ran all the Docker steps. So it did some authentication, it loaded Docker ignore. Here is where it's pulling from Python 3.11 Alpine. It does that for a bit. Finally, it runs Python to install Poetry. A lot of output in that. And then it exports our layers. Finally, it pushes those up to our container registry. So, is it actually there? Well, let's go find out. If we go back to the top of this page, we can go over to code. On the right side, there's now a packages here, container build workflow. This was automatically associated because of the OCI label I put in the Docker file. We'll go over here, and you can see it's got this image here, pushed about 2 minutes ago, and yeah, we've got our Docker image. What if we wanted a tagged version? Let's add a tag and then run the workflow manually. So let's do git tag 1.0.0, and I will do a git push origin 100. Now we have a new tag. Let's go over here to Actions, Build Container. We've got a workflow dispatch trigger. We can run the workflow here. But rather than branch main, I want to go tags 100, and then we'll run the workflow. And let's see if we get another container that is tagged. Here it is, it's put in the container, and in about a minute, we should have our new image. Okay, the workflow ran. Let's go back to code, go over to our packages, and yes, we do now have an image that is tagged 1.0.0. So that all looks good. And that covers the basics of using GitHub Actions to build a Docker container. I hope this was helpful. Help me out and the channel by hitting those like and subscribe buttons. And I'll see you next time. Thanks for watching.